This morning we're going to talk about basically the reason for logs and how to put it in log notation. The reason for logs is to be able to figure out an exponent. So, exponent. So if we were to have something like, let's say, 2.3 raised to the x power equals 7. This problem is kind of hard to figure that out because you have to be able to plug it in your calculator, and you got to plug it in several times to be able to get it to work. So for example, let's say 2.3 raised to the second power. Well, that's going to give me 5.29. So 2.3 raised to the second power is 5.29. That's obviously too small. So let's try 2.3 raised to the third power. Well, 2.3 raised to the third power is 12.16. Too big. So it's kind of like the Price is Right. You can't go over. So now let's try 2.3 raised to the 2.5 power. 2.3 raised to the 2.5 power is 8. Too big. So let's drop it down. And this process could keep going and going and going. Well, there is a way to figure that out, and it's using something called logs or logarithms. So we have a couple different videos that are going to work on this. The first video is just being able to write this into log form. So there's a few things that we have to figure out first. This 2.3 is called the base. And our x is called the exponent. It's little and it's raised. And then it equals 7, and we're going to refer to this as our answer. Now, if we wanted to write this in log form, we basically would it would be log, little base, it's a subscript, of the answer equals the exponent. So if I were to put this in logarithm form, my base was 2.3, so I'd have log base 2.3. Notice 2.3 is written little and it's lower than the log. And then my answer was 7, and that equals x. Now I could plug this into my calculator and figure out what that is, an exact answer for that x value. And we're going to learn in a different video how to do that. So let's try another example. If I were to have, let's say, 2 to the third, well, we know that equals 8. But if I had to write that in exponential, or that is exponential form, if I would write it in log form, my base is 2, this is my exponent, and this is my answer. So I'm going to have log base 2 of 8 equals 3. And that's how I take, this is exponential form, and this is log form. Now, that will help you on page in your packet. That would help you with problems 67 to 76. So page 8, numbers 67 through 76. That example will help you. So let's try a different type. What if I have the log notation? Let's say log base 4 of 10 equals, I don't know, let's say p. And I wanted to write that in, so this is log form. And now I want to change that to exponential form. So here is my base, here is my answer, and here's my exponent. So our base, big 4, exponent, p, equals 10. Or if we had, we'll do one more example like that. If we had, let's say, log base 49 of 1/7 equals negative 1/2. So again, let's locate the base. Our base is the little number there, so in our exponential number it actually becomes the big number. So 49, this is our answer, here is our exponent. So we have 49 to the negative 1/2 is equal to 1/7. That's it. So that's how you take exponential to log form and then logs to exponential. These bottom two examples will help you on page 8, numbers 57 through 66. So why don't you go try some of those out. You can check yourself, or actually there's answers on page 11, but if you're not understanding, just send me an email, or if you're in class, come up and ask.